Today I am going to show you how to find out the derivative of product of two functions of a single variable. So let x be a variable and two functions of x are fx and gx. Okay. Now this is a very commonly used formula what we write as ddx of fx into gx, but we generally do not dig down how to find out this formula from basic definition of derivative. Today I will show you how to find out the derivative by definition. Okay, so fx and gx, we want to find the derivative of that. So from definition we know f dash x equal to ddx of fx, right, which is nothing but limit h tends to 0 f of x plus h minus fx whole divided by h. H is nothing but an infinitesimal small object which tends to 0. So if so, obviously g dash x will be ddx of gx limit h tends to 0 g of x plus h minus gx whole divided by h, right? But we do not know how to find out their product, their derivative. Let me write it that way. Limit ddx of fx into gx, let me keep it in bracket as a single function of x once again. So by definition it will be limit h tends to 0 f of x plus h g of x plus h minus fx gx whole divided by h, right? So the same expression can be written as, I am just adding one expression and subtracting one expression in the numerator to keep the balance. So what is that? I am writing as limit h tends to 0 f of x plus h g of x plus h, let it be same. I am just subtracting f of x into g of x plus h, right? Similarly, to balance, I have to add it as well, fx into g of x plus h. So these two things I have added and subtracted and kept the numerator same, and the last expression will be as it is, that is minus fx gx whole divided by h. So this will be my final expression to evaluate the derivative of the product of two functions. Okay, now I am simply removing this part and I will show you the next steps in the upper section. So I am writing it once again here. So it should be from the first two expression, if you take g of x plus h common, so let it be limit h tends to 0 g of x plus h. If I take common from the first two expression, my expression becomes f of x plus h minus fx whole divided by h. I am separating the entire expression into two limiting expressions plus another limit h tends to 0. If I take common from the third and fourth expression fx, that is, if I take common fx from the third and fourth expression, it becomes within bracket g of x plus h minus gx whole divided by h, right? Now if I remove this portion now, so you can understand my derivative will be, since in this part I have to put the value of h as 0 because h is tending to 0, so obviously it will be gx, and limit h tends to 0, the other first portion will be f of x plus h minus fx whole divided by h plus fx. Fx is not familiar with the, or fx is not related to h, so I can take fx out of it, and then I can write the second limit as limit h tends to 0 g of x plus h minus gx whole divided by h, right? So from the basic definition that I have written in the initial part of this video, from the definition we know this is nothing but f dot x, that is ddx of fx. Similarly, if I take common from the first expression, fx becomes, and here it is nothing but g dot x, right? From definition, the derivative, it is limit h tending to 0, f of x plus h minus fx by h, or similar for g. So my final expression becomes ddx of fx gx, that is their product, equal to f dash x, that is ddx of fx into gx, plus g dot x into fx, that is derivative of the first function into second function plus derivative of the second function into first function. So this is the way, by definition, how we derive the formula of product of two functions of a same variable. I would like to request you to view my video, and if you like it, I will request everyone to watch, subscribe and like my channel.